In this lesson, we will explore the different ways of representing a vector. Before we explore the ways of representing vectors, let us go back to our previous lesson and see where we stopped. In the previous lesson, we saw how to represent a vector in terms of its components. Specifically, we represented a vector v bar as follows. V bar is equal to v cos theta, units of magnitude along x-axis, plus v sin theta, units of magnitude along y-axis. If you see the above equation, you will find that writing the wordings, units of magnitude along x or y-axis, every time is little frustrating. So our next step would be to try and find a solution to represent these wordings in a simpler way. We will now discuss the concept of unit vectors, which we will use in representing vectors. A unit vector is a vector that has a magnitude of exactly 1 and points in a particular direction. It lacks both dimension and unit. Notice that the definition of unit vector says its magnitude is 1. It does not specify any units, like 1 centimeter or 1 meter, etc. Its sole purpose is to point, that is, to specify a direction. The unit vectors in the positive directions of the x, y, and z axes are labeled I hat, j hat, and k hat, where the hat is used instead of an overhead arrow as for other vectors. Let us take the vector v bar, which we defined previously as v bar is equal to v cos theta, units of magnitude along x-axis, plus v sin theta, units of magnitude along y-axis. Now to write the wording, units of magnitude along x-axis, each time for every vector would be a tedious task. Instead we use the concept of unit vectors to replace this wording. The fact that a unit vector has a magnitude of 1, with no units, means that if we multiply a unit vector by a scalar having units, the resulting vector has a magnitude equal to the magnitude of the scalar, with the same units as the scalar, but is directed along the unit vector. We have now identified that I hat is the unit vector along x-axis. So the vector defined as v cos theta, units of magnitude along x-axis, can now be represented as v cos theta times I hat. Similarly, the vector v sin theta, units of magnitude along y-axis, can be represented as v sin theta times j hat. Therefore the vector v bar can now be represented as v bar is equal to v cos theta times I hat plus v sin theta times j hat. Therefore v bar is equal to v cos theta, units of magnitude along x-axis, plus v sin theta, units of magnitude along y-axis, is equivalent to v cos theta times I cap plus v sin theta times j cap. Unit vectors are very useful in representing other vectors. Recap of the concepts we discussed in this lesson: unit vectors and unit vector notation of a vector. Notice that each topic gives inputs to proceed to the next topic. so it is important to read them in the same sequence.